The next thing, or the next topic I want to cover with y'all is logarithm equations. Now, logarithms have properties, and the one we're going to look at, or I'm going to demonstrate first, is that if you take the logarithm of some number and you're multiplying the two numbers, the rule is, or the property is, that you take the logarithm of the first number and you add it to the logarithm of the second number. Sort of like this. 5 times 7 equals, now everybody knows that answer is 35. Now what I'm not going to use logarithms to solve for that to give you 35. But what I'm trying to show you is if you're multiplying 5 times 7, then you would take the log of both sides. And naturally, most times you don't know the answer, but for our purposes, we're going to leave the answer. Now, here's where we want to begin the root. Mr. Napier said, if you're taking the logarithm of a product, you would say the log of the first number, 5, plus the log of the second number, 7, would equal to the log of 35. Now what I want to show you here, or try to prove this, if you go to your calculator and you find the log of 5, and I did, and I found it to be 0.6990, plus, and you take the log of 5, and I found it to be 0.8451. And then you go to and add those two up, and then you go to your calculator and actually take the log of 35, you will see that this sum is the same number on your calculator for the log of 35. Now, that's the arithmetic part. We're trying to generate an equation. So, let's take and say that we don't know what this 5 is, and so we're going to let x stand for that 5. So x is 5 plus log. Now if it's 7, that would be x, which is 5, plus 2. Equals log 35, and what that generates is a logarithm equation. Now that's what we're going to try to do, is to see how do you how would you solve this problem? How would you actually take that and find out what x is. And so what we're going to do is to use, or try to enhance this, and that kind of matches out. So so here you have the log of 5 plus the log of 7 equals the log of 35. Well, over here, this is the log of x plus the log of x plus 2 equals the log of 35. Now, the thing about solving this equation, and I'm hoping this will be something you see, that what we're doing here, what I'm trying to do is to go from backwards. In other words, we're going to take this and go backwards. With this is what I'm trying to say. You have log 5, log 7. Well, prior to that, we had log 5 times 7 equals log 35. So over here solving the equation, we're going to write not log x plus 2 again. We're going to write log x. Now since we're adding logarithms, now Mr. Napier's rule is if you're multiplying two numbers, you add the logarithm. So if you're adding the logarithms, that means you are multiplying the two numbers. So we're going to put x plus 2 equal log 35. Now, if you go back over here where the numbers are, and we're going backwards, we just drop the logs. So over here, if we go from here, we're just going to drop the logs. Now, I hope that we can get this, understood, and the rest of it is easy. This is simply an equation where we have to distribute or remove the parentheses, the expression is. In this case, you would be doing distributing. You would say x times x, that's x squared, plus 2 times x is equal 35. Now what do you call an equation that has a variable squared? I'm hoping that you have heard that enough that you will be saying, well, that's a quadratic equation. Rule number 1 must equal 35. So we have x squared plus 2x minus 35 equals 0. Factor. Trial and error or simple? I hope you said simple. But two numbers multiply together give you 35. But if you subtract them, you get 2. Now remember, when you subtract, the sign of the larger number is the same as the middle term. And so x is equal to -7 or x is equal to 5. Now, think about it. Logarithm of x being -7. If you go over here and replace x with -7, you cannot find the log of a negative number. So we call that answer an extraneous solution. Not a wrong answer, just an extraneous. So we must write solution sets on equations. Every time we're solving these equations, at the conclusion, you must write your solution set. And so that is, we're not trying to do the numbers over here. We're trying to solve equations. And they'll start out with logs. And then how do you get to the x times x plus 2? And I'm hoping that you kind of got a picture of it. We'll see if we start doing some more problems. Now, so Mr. Napier has this rule that the log of some base, when you're multiplying the two numbers, the rule is you take the logarithm of the first number and add it to the logarithm of the second number. Now that's multiplication. Division. Mr. Napier's division says if you're taking the logarithm of multiplication, division, then you would take the log of the top number, meaning the numerator, and subtract the logarithm of your denominator. That's the process that we're going to do now. And to try to give you a picture of it, that'd be like this. Say, for instance, you want to know what is 42 divided by 6. Well, everybody knows the answer is 7. Well, Mr. Napier's log rule would have been something like this. You would have said the log of 42 over 6. And of course, what you do to one side, you would have the log of 7. Now, following this, Mr. Napier said that if you're taking the logarithm of a division, you would say log of the top number, 42, minus the log of 6 equals the log of 7. Now, what I'm trying to do here is to generate an equation for us so we can use something we see here with these numbers to use when you're using letters. So say, what if we don't know the 42? So we put x minus the log of 6 equals to the log of 7. Now, how would you solve this problem for x? How would you use that? Well, if you remember now, up here, Mr. Napier is saying that if you're subtracting logarithms, previously you were dividing these. See? Previously you were dividing. Now, if we look over here where we have these, then previously we did not have the logs. If you have the logs on both sides of the equal marks, and we're going to solve for x, what we do is literally drop the logs. Now, multiply both sides by the denominator of 6. Opposite of division is multiplication. So, that cancels, so x is 42. Now, you still have to check for x, but you're taking the log of 42, and it's not going to be extraneous. I don't know if doing these numbers helped or not, because I can't get back to you, but time now is to employ or work some problems. And this is some problems off a worksheet that I will have out for you to see. So let's begin. Get here. Number 1. So you're taking the log of 4x plus the log of x, and you're trying to determine what x is equal to. What is this letter replacing? So if both of them had log previously, then you were taking the log of 4x times x. In other words, Mr. Napier says if you're adding logarithms, previously you were multiplying two values. Log 36. Now basically what we're doing is going backwards, so actually just, you got logs on both sides, just write the product equal 36. And that is how you solve this equation. If you're adding logs, previously you were multiplying the two values. Now, of course, we divide by 4. X squared is equal to 9. Take the square root of both sides. X is 3. Now, truthfully though, x is equal to a plus or minus 3. But if you take the answer of x equal to a negative 3 and check it, it will not work because the log of a negative 3 is, you can't find it. There is not one. So you would end this by putting your solution set. And that's how you will solve an equation, a logarithm equation. Now, this is number 2. Okay? You're adding logarithms. So that meant previously you were multiplying 2y times 5y. It equals log of 160. Now, then if you have, you're solving for y now, so we just literally drop the logs. And we just multiply these two values, and that's 10 y squared. Nope, drop the logs. So we're working kind of like backwards. If you started with this bottom, then you would do this. You would put log on both sides, and then you would put log of the first number times plus the log of the second number to continue on. But we're going in this direction. So where we write the product and then we drop the logs. Well, now this is an equation that we have to solve. Now we're going to use what we call the square root principle. Not going to factor, we're going to use the square root principle. That means we're going to eliminate the 10. And y squared is equal to 16. Take the square root of both sides, and y is 4. Now try to understand, yes, it is 2 answers, plus or minus 4, but when you have negative 4 for x, and you come back to the top and replace the y with negative 4, you would be taking the log of a negative number. And that we cannot take the logarithm of a negative number. So finish it up with your solution set. And that's the product of where you have the pluses. Now we're going to do the negative. Now, don't forget, when you're subtracting logarithms, that meant previously that you were taking and dividing the numbers prior to that. Well, everybody knows that the 4 and the 12 cancels, so you have the log of 3x equals the log of 5. Now, since we're solving for x now, and since you have logs on both sides, we just write it without. Don't even put it. And then you divide by 3, and you have x equals to m. Proper fraction, we change to a mixed number. Now, that's a positive number, so we don't have to worry about it. Well, we still have to worry about it, but the chances are strong that it works. And so you finish it up with your solution set. Now, let's try number. Now notice I have 14. Well, that's the number on the worksheet. So the worksheet I will post for you later, and it'll have all of these problems on it, plus the others which I want you to complete. Now, again, we're subtracting logarithms. So previously, now it has a base 7. Previously, we were dividing these. Now, I failed to tell you this. So let me go back and inform you on this. If your log does not have any base, everybody knows that that's 10. In other words, this would be the base, and it'd be an understood 10. As always, Mr. Napier's numbers was changing everything to a power of 10. And so since everything should have been to a power of 10, he just didn't put 10. But if you change the base, and it's something given, like in this problem, it's 7, and you got to put the 7. Now you don't have to put, up here, you don't have to put the 10s. They're understood. But if it's not 10, in this case it's 7, you must keep it. Well, let's continue on. So if you have 4y plus 3 over 9 equals to this, what you're doing next is just literally drop the logs, even though it's base 7. So the 4y plus 3 over 9 is equal to y minus 3. Now people, this is, I'd like to show it like this. We need to get rid of this 9 on the bottom. So what we'll do is multiply both sides by 9. That will cancel out. And of course, what you do to one side, you do to the other. And that way we won't have to worry about trying to solve a fraction. We just have that's not a decimal. Now, let's mark them on the board. Now, let's see if I can get it out of your way. Nope, can't do that. Nope, can't get it out of our way. Let's see. Erase it. I can erase it. Okay. Now, we have to solve this equation. That's just a, boy, aren't you glad that you know how to solve this type of equation? See, it's not even a challenge anymore. This is one of those little algebra problems where you subtract 4y from both sides, add 27 to both sides. So 30 is equal to 5y. You know how I'm doing this, I'm sure. Divide by 5. And y is 6. Now you do have to check for extraneous solutions. And 6 take away 3 will not be a negative. You just cannot have a negative to find a log. So that is the conclusion of that number 14. And now, of course, that's division. Now remember, Mr. Napier said if you're subtracting logarithms, or in this case, if you're dividing logarithms, you were subtracting logs. Number 5. Let's say number 5. No, the next one is number 7. Next one is number 7. Now, we're going back to what we did earlier. For instance, what I'm trying to say to you, this 1/2 is the power of what follows the word log. So what you would do here is to rewrite log of x to the 1/2 power. Plus, since we have another 1/2, that's the power of what follows. So that would be the log of x plus 5 to the 1/2 power. See, we're going backwards. That's sort of, when you drive in a vehicle, going backwards is a lot harder than going forward. And that's what we'd have to realize. we're going backwards to solve these equations. We're taking bringing the number in front of the word log and making it a power. Yes, and you know this, that if you're taking something to the 1/2 power, that's the same thing as taking the square root of that value. So this is going to be log square root x plus 5 is equal to log of 6. Now, when you're, remember, going backwards, so if you're adding logarithms, previously you were multiplying these two. Now, I hope you caught on to that portion of what we just did. Anything to the 1/2 power is the same thing as taking the square root of it. We want to use the radical sign when we're solving these equations. Now notice that you have the log on both sides. Well, we're going backwards, so we just drop them. So then we just have this equation to solve. Now, how do you solve this particular quadratic, the square root of x times the square root of x plus 5 equals 6. A multiplication of radicals. My expression is, you say inside times inside, and the answer remains under the radical. Now, we got everything in the radical, so now we call this a radical equation. Now, I hope you recall how we did it in the past. Catch it means put a parentheses around it. We want to eliminate the radical. So let's eliminate the radical by putting parentheses and raising it to the power of the index. And what you do to one side, you do to the other. So, what is the square root of anything squared itself? Now I'm going to go ahead and distribute this, so it'll be x squared plus 5x with no radical is equal to 36. Now you notice that we have a variable squared, and everybody knows that's called a quadratic equation. And a quadratic equation, I'm going to come over to the side here, a quadratic equation says it must equal 0. So we have x squared plus 5x minus 36 equals 0. Factor, simple, or trial and error? I hope you said simple. What's some factors of 36? Let's subtract to give you 5. 5 and 9. Now when you subtract, you cannot have two negative signs. No, no, no. Only one. Now which one is positive and which one is negative? We all know that the sign of the larger number is the same as the middle term. So we have x is equal to a negative number. We've got to take that out. Oh, let's check out that negative 9 in the original problem. I mean, you have to go all the way to the top. All the way to the top. And up here, if you put all the way to the top, if you put a negative 9 in there for that x, you're taking the logarithm of a negative number, and there is not a negative. So he's out. He's extraneous. Now 5 works. And so you write your solution set with only one answer, and that's 5. Now what if you had no answer? That would be an empty set. So that's how you do number 9. Now let's try another. let's get this one and see how you'll do on this one. Again, it starts out with 1/2 log. That's a power. So we have to rewrite this as log of c plus 1 to the 1/2 power. Plus, again, he's got a fraction. So that's a power of what follows the word log. So that would be log c minus 4 to the 1/2 power and the log of 6. Now everybody knows, and I hope you do too, that the number raised to the power of 1/2 is the same thing as taking the square root of it. So we're going to replace the 1/2 with the radical. The radical means taking something to the 1/2 power. And since we are adding logarithms, that meant previously we were multiplying two items. And those are the two things we're multiplying. So we're working our way backwards. Instead of having the logarithm of the square root of c plus 1 plus the log of that, we're going to rewrite it as the log of something times something, backward up from Mr. Napier's rule. Now, if you got we're solving for it, if you got logs on both sides, we just drop it. But let's just go ahead and remember, when you're multiplying radicals, you say inside times inside, and the answer stays inside the radical. Nope, we don't write the log. We're getting rid of it, so it'll be equal to 6. Now, people, we have that radical equation again. Now, so the expression is, I hope you remember, eliminate the radical. Eliminate the radical by putting a parentheses around it and square it to the power of the index when the index is 2. What you do to one side of the equation, you must not multiply by 6, but take it to the power of 2. So the square root of anything squared is itself. But let's go ahead and FOIL this while we're doing it. And of course, that's c squared. Outside's negative 4x. Inside is positive 1x. That gives you a negative 3c rather. And the last times last is negative 4. And 6 squared today is 36. So young people, we've gotten back to the being a quadratic equation. Rule number 1 must equal 0. So you have c squared minus 3c minus 40 equals 0. Trial and error or simple? I hope you said simple. C and C. Tell me two numbers that multiply together give you 40, but subtract to give you 3. And when you subtract, no, you can't have two negatives, only one. So which one is negative? Well, the sign of the larger number is the same as the middle term. So we have C equals 8, or C equals negative 5. Let's check out negative 5 again at the top, at the original. Well, negative 5 plus 1 is negative 4. No logarithms of negatives. He's out. Now remember, he's not a wrong answer. We don't call him he did something wrong. It's just what we call extraneous. So the solution is set of C's such that C equals 8. That's number. Now let's go to the next type of problems. You see, this is back, and let's see how we do on this one. So this is, now look, we're subtracting logs. So that means, now we got to keep the bases, got base 2 now. So previously, if you're subtracting logs, you were dividing, or you had this over 2 equals. Now over here you're subtracting. So you'd have log base 2. Now that means you were dividing. In other words, this subtraction means you were dividing. The numerator is y plus 5, the denominator is 4. Now we're back to them rewriting it without the logs. This is both sides, you see. Now, we have a name for this type of problem, and I hope you remember your little bit of algebra, or rather geometry, when we started talking about proportion. Everybody knows that it's called cross multiply. Now, we're not talking diagonally, I mean straight across, we're talking diagonally. So that means we're going to say 4 times 2y minus 5 equals 2 times y plus 5. Now, we go from there. We know this is called the distributive property, so 8y minus 20, 2y plus 10. Now, everybody that knows anything about mathematics, when you have the same letter on 2 sides of the equal marks, you can't have that, and one of them is going to have to go. Now, normally it's the one on the right, or the smaller one, or the negative one. So that's 6y. Now, you see as well as I do, that 20 doesn't have an x or a y. It needs to go. So I'm going to go over here to the side to complete it. So we have, I'm going to go to the side and rewrite that. So that'll be 6y. Now we know that's gone, and that's gone. Is equal to 30 divided by 6, and y is 5. Now write your solution set, and you have finished that time. Now, I hope that kind of generates you an idea. Now, these next 3 problems, they're not tough, but they're just a different approach. They're not even, you've got to take a different way. And I'm going to extend it up a little bit. I say I am. Now, if you look up here, you have the log base 4, log base 4, but the 3 on this side does not have the word logarithm. Now, I did not forget the log on the 3. It does not have one. But we don't really put a lot of change to it. We just got to keep, well, let's watch. This is still adding logarithms. So you would still write log base 4, and since you were adding, that meant that you multiplying 3y plus 1 times y minus 1. Now, what you would have done earlier is you would rewrite this without the logs. But since the 3 does not have a log, then we've got to use Mr. Napier's rule again. Now this is going back to your last session on finding the logarithms. Mr. Napier said if you're taking the logarithm of a number raised to a power, you are to put the power equal to the log of the number. So this fella is the base. The 3 here is the pi. I'm jumping ahead there. And this is what it equals. So you would rewrite this as 4 to the power of 3 equals. Now let's go ahead and FOIL again. So that's 3y squared. Now the outside is negative 3y, and the inside is positive 1y. That gives you negative 2y minus 1. Now, 4 to the third power, 64, is equal to 3y squared minus 2y plus 1. Now, quadratic equation must equal to 0. 3y squared minus 2y minus 65. Now, that's a quadratic equation. Everybody knows the factor. Trial and error are simple. Well, we've come up with one of these trial and errors. Now, over to the side, do we know that 3 is 3 times 1? So we put the first one is 3y and the second is 1y. Now let's take 65 and determine some factors of him. And everybody knows that 5 will go into 6. That's 13. Now people, that's the only factors other than 65 times 1. So we're going to try this. 5 here, 13 there. Now, the outside is 15y. The inside is 13y, and we subtract and get 2y. It's going to be negative, negative, plus. So the 13 is plus, and that's the trial and error. I hope you haven't forgotten how to do this. So y is equal to a negative 13 over 3. Y is equal to a negative 4 1/3. Or y is equal to 5. Now, if you go back and check that negative in the original one, that's negative 4 1/3 and minus 1, and that'll be a negative number, so we cannot have that. So the solution set is y, such that y equals 5. Now, if I really look at it, we didn't really use this. We just would try to remember that what we're doing here is so we're taking the base to that's the power. And that's how you do that. So of course, quite naturally, you can't stop with that. You got to see it again. So here we go. Well, we got a little work to do here. That number in front of the log is the power of what follows. So we have log base 3 y minus 2 squared. That 2 is the power. Now when we use minus log base 3 y minus 4. Now we didn't forget that to log. 2 doesn't have a log. But we can't do a lot of dropping here. Now, if you're subtracting logarithms, then that means the log of 3 that you were dividing. So you have y minus 2 squared as a numerator and y minus 4 as a denominator. Now, since the word number 2 doesn't have a log, we got to go back and use the setup that this is the power, base rather, this is the base, and this 2 is the power of the base. So that would be 3 to what power 2 is equal to, now go ahead and square, let's go ahead and square that. Square the first term. Multiply your first term times your second term and double it and square a -2, and that's a +4. Now, we all know that 3 squared is 9, so why don't you just cancel it out like that and put 9 in front of it. So, we got a quadratic equation again, so subtract 9 from both sides. So we have y squared, and it's really 0 equals, but we're not going to put 0 equals, we're just going to write in last. Now, trial and error, simple. I hope you said simple this time. That's going to be 2 sets of parentheses. Tell me 2 numbers. If you multiply them, you get 5. 5. But if you subtract them, you get 4. Now, when you subtract, you can't have 2 negatives. So y is equal to 5, or y is equal to -1. Oh, check that boy out. What about -1? Go back all the way to the top. Now that means -1 minus 2 is -3. He's extraneous. Can't be part of our solution. So the solution set is equal to 5. And that's how you do that. Now you know I've got one more, and let's see how you do that. Now remember, I did not make a mistake and leave off the word log. He just does not have one. But, look at this. You are, okay, let's get him back down here. You were adding logarithms, so that meant, I can't drop the word log yet, that meant you were multiplying this and that. Equals 6. Now, 6 doesn't have a log, so we got to go back and use the definition that means this is the base. Now this 6 without the word log is a power of the base. So we have 2, the base, to the power of 6 is equal to, now again, I'm going to go ahead and FOIL this. This is FOIL. I'm going to go ahead and move the parentheses. So that's 2y squared. Now the outside is 2y. The inside is minus 6y. So that'll be a minus 4y. And last times last, not last plus and last times. That's -6. Now again, we're going to do this little deal here. We're going to say 2 to the 6, and everybody, if you really sit there and calculate and think about it, you will know that that's 64. So now we're going to, must equal to 0, because it's a quadratic equation, subtract 64. Subtract 64, and I'm going to say something here and see if you remember this when we're talking about factoring. What is the first thing you are to do when you are factoring? What was the first thing that you do or look for when you start factoring? Do you remember I said a common factor? I hope you recall that. So what number divides into all 3 of them? 2. So factor it out. That gives you y squared minus 2y minus 35. Now, continue on. Factor that. Trial and error, simple. I hope you said simple. Y and y, 7 and 5. Now when you subtract, you can't have two negatives, only one. So the sign of the larger number, in this case 7, is the same as the middle term. So the answer is y equals 7 or y equals negative 5. Again, check out old negative 5. Can you take the logarithm of a negative? You got to go all the way back to the top. Now, I want you to think this. If it works, if it works one place but not another, it can't work for all of them. It's got to work for all of them. So the solution is set of y's such that y is equal to 7. Now, people, that's some examples off that first worksheet, and I'm going to have it posted for you, and so you can work along with another sheet that now, that completes this video.